Hello everyone, good evening. Welcome to Ganit. Pardon my voice today, I'm not at my best today, really. I have a little bit of cold. So, we are going to continue today, really, in that same set of questions in exponents we were doing in the last class. So, in exponents, I have at least 8 to 10 more types of questions we are going to discuss. We are going to start with something that we practiced in the last class as well. You could see it here. So, this is the type of question we are going to do. Let's see. So, we have a question, uh, 7 to the power 2n plus 3 minus 49 to the power n plus 2 whole upon 343 to the power n plus 1 and then whole to the power 2 by 3. Now, this is the question we have to solve. Uh, what we learned in the last set of questions was the concept of this thing. 3 to the power k plus 1 can be a double-sided arrow, and we can write it as 3 to the power k times 3 to the power 1. We have learned this law from this to this side. Please remember, if you see something like this, you have to know how to write it like this. All right. First thing. Second concept that will be very important in questions like these, we need prime numbers. You have to understand any kind of composite number is a massive red flag. We don't need red flags in our question, guys. Come on. So please understand, composite number, we have to avoid. If there is a composite number, try and break it into a prime number. All right. So we need prime numbers in our exponent questions. Prime numbers are good. We need them. All right. So we have 7 to the power 2n and 7 to the power 3. How? From this rule, minus 49 can be written as 7 squared, and then we have an n plus 2 above, and then we have a 7 to the power, how much? 7 to the power 3, I believe, and that to the power n plus 1, and that whole thing to the power 2 by 3. Please don't worry about so many exponents. It's just going to simplify. Eventually, it all simplifies. Please understand that. So now, okay, here a lot of you make a very small error and it costs marks, a lot of times. So please remember, you have a 2 and then there is an n plus 2. This is that sort of situation. So you'll have to write 2n plus 4. A lot of times you write 2n plus 2. That's wrong. Please understand. 2 is being applied to this n plus 2 entire expression. It just does not apply to the n. All right. So we have a 2n plus 4. So I'm going to write this further. So I have a 7 to the power 2n, 7 to the power 3, minus 7 to the power 2n, and 7 to the power 2. Sorry, my bad. I just said not to write 2. My bad. 7 to the power 4. And then this becomes 7 to the power 3n plus 3. And this whole thing being multiplied with 2 by 3. Remember, the 3 in denominator will cancel the 3 and 3 in numerator. So what we will get is this. 7 to the power 2n, 7 to the power 3, minus 7 to the power 2n, and 7 to the power 4 upon 7 to the power. So 3 and 3 will cancel. You will cancel it out. And 2 is still outside. Remember that. So that 2 will multiply to n plus 1. It will become 7 to the power 2n plus 2, which eventually is what? 7 to the power 2n times 7 to the power 2. So we solve this further now. 7 to the power 2n is being repeated, so we will assume it as p. Remember, every time you see a question or a question where something is being repeated multiple times in numerator and denominator, please assume it as a simpler variable, a p or a q or a x, whatever you feel comfortable with. So the whole question will change. You have a 7 to the power 3, so 343 p minus 7 to the power 4. I have no idea what that is, so I'm going to multiply 343 with 7. So in 7 3 21, 1, 2, 7 4 28 to 30, 0, 3, 7 3 24. So I have a 2401 p by, and we have a now 7 to the power 2n. So 49p, right? So I will solve it further. This is going to be a negative answer, guys. That is a pretty much that is pretty much a possibility. Please do not think that you cannot get a negative answer in exponents. This question is a living proof of that. You can get a negative answer. Please remember that. All right, so we're going to solve this. 11 minus 3 is 8. 10 minus 4 is 6. 0 and 2. So this is what we have, I believe. 343, 168. Sorry, 58, my bad. 2058 over 49p. We have a p which gets cancelled. I'm hoping this cancels with the negative sign. This cancels by 7. So 7 sevens are 49. 65, 7 nines are 63, 28, so 7, 4, and then probably again by 7, 7 fours are 28, and then 2. So the answer is negative 42, guys. Remember, the advantage of P is it gets cancelled. The advantage of any variable that you are substituting is that it gets cancelled. Because when you see a question like this, especially in an exam setup, the first thing that hits you is my answer going to have a variable in it, an n or an x? So many variables in the question, it's very natural to think about, but it won't. That's the advantage of using P or a Q, whatever you want. All right. Please take a note of this. We'll catch up later for the next question. Thank you.